Last section in chapter 10, 10.5, abuses of statistics. All right, not a lot to write on these, but a few notes to fill in. And show you some examples in your textbook too while we're at it. So statistics can be abused quite easily, and they are abused quite regularly. So I want you to start thinking about, as you see statistics in the media and the world around you, asking the questions that are sort of proposed in this, because sometimes the information you're presented with makes you a little bit curious as to if that's really what's going on. So here's some of those kinds of examples that I'm referencing. The first question is about the sampling process. So these are some of the things that are concerning when you have data. Who did they ask? Because if they ask people at OBU or they ask people at OU, they're probably going to get a little bit different supply of answers, right? Who was asked? How many people were asked? It's quite different if I ask 5 people than if I ask 500 people. Not only that, but how many people responded. So if I send out a survey to 1,000 people and 500 of them respond, well, 500 responses is good, but that's only 50%. Those other 50% might have had a very different kind of an answer had they responded. Was the sample random? Did we pick everybody in our classroom, in which case we're getting a predominant female perspective, right? Or did we, yeah, I know, Andrew, right? Or did we make sure that we just sort of picked every 5th person that walked into the GC? That would be more random, right? I know we'd still have more females, but we wouldn't have this many. Okay. How was the question worded? This is a really tricky one because sometimes people word questions in such a way that you think you're supposed to answer it one way or another for one reason or another. Either there's a lot of negations in it, like it has a lot of nots and you can't almost even figure out what you're answering, right? There's sometimes that'll happen. But sometimes the very question itself is going to give you a tainted response. For instance, if I stand outside the GC and I interview everybody who comes in and I say, do you drink alcohol? I might not get everybody to respond honestly because you might sort of sense that the right response is this, even if the other response is true. There's some sort of a sense of how is the person interviewing this going to perceive what I say. So there's some kind of issues with that when you're looking at data. Okay, so this is all in how the data is collected. The other issue is how the data is reported. And in particular, we've had graphs that we've been doing most of. So we've talked about some of these. You need a title, right? The title gives a lot of information. Without it, man, that data really might not be what you thought you were looking at. Labels on the axis or pie chart pieces. Same thing. It's the exact same issue, right? It may not be quite what you thought you were looking at. The source of the data. Okay, so if the data is collected from Harvard University, it would look different if the data is collected from Texas A&M or whatever like that. Okay, so if there's an actual source of the data, it needs to be included somewhere on there. And it might be included in the title, but somehow it's reported. A key to a pictograph or a stem and leaf plot. That's kind of like the labeling issues, right? What does it actually mean? What does this data mean? We got a few more. I've got one more slide. Uniform size and the symbols on the pictograph or dot plot. We talked about that when we were creating these, right? There's an illusion that something's going on if you accidentally or intentionally make the font size or the size of your pictures or the whatever somewhat different. Scale, does it start with 0? And if not, is there a break shown in the graph? Another scale issue, are the numbers evenly spaced? Right? We talked about that last time when we looked at our box and whisker plot, or the box plot is what your book calls it. If you don't space the numbers appropriately apart, it looks somewhat different. The data is misleading. And the last one is 2D and 3D effects, which we haven't seen. So if you've got your book, or if you don't, look at a neighbor who does. I'm going to show you what I mean by the 2D, 3D misleading facts, okay? So turn to section 10.5, and I never remember what problem it is, but I can tell you once you turn there. And it's not the problem, but the section before the problem, like the information before it. Excellent. Okay, take a look. We're going to go to the section before. Take a look at page 606. 606 is a great example, both what's on top and what's on bottom. There's 2 graphics on the page. All right, so the top one, you'll notice that they have made something 3-dimensional, right? And what it was the size of something. What did we have? Oh, and the page before shows the two-dimensional version of it if you flip back and forth. Boxes and, what does it say?
Boxes of corn, crisps, and
Boxes of, this is like sales, the number of that are sold, okay? So if you look at the two-dimensional graph, flip back to page 605. What they're telling you, if you look at the frequency on the left-hand side, you can actually see that the boxes of the Sugar Pops is at what level? 2? And the boxes of the Corn Pops is at 8. So that should be telling you that there's 4 times as many of them sold, right? But that box is not 4 times the size. Do you know what it is? It is 16 times the size. And if you've had measurement with Dr. Marsh, you might have seen that before. This issue is that they've sort of multiplied the height and the width both by 4. I see it too, I know. Okay, so you see the 2D problem, and it's further accentuated in the picture that's 3D, right? It even looks worse, doesn't it? Okay, look at the bottom graph, where it's got the circle graph and the bar charts. Let's start with the circle graph for a minute. It's page 606. Look at some of the percentages on that circle graph. What do you see? That green one is how much? 27%. And what about the top light blue one, lumber?
23.
Does it look like that those are about equal in terms of the picture you're seeing? No, but their percentages say that they should be, right? It's because they've turned it into a 3D image graph. And so it gives the illusion that something's happening that's not really happening. Okay, so that's what the 2D, 3D misleading facts is about. Okay, everybody good with that?
Yeah.
All right.
So